Hi, I'm Mr. Peeranat Prasongsuk. I work as a geospatial data analyst at the IBIT Company Limited from Thailand. Today, I would like to share some technique from my experience for the optimizing cloud optimized GeoTIFF for faster access and better OGC EDR performance. So first, I would like to describe for the era of the evolution of raster data. So the first evolution of the raster data is started at the 1960s, 1960s to 1970s. It's called the early era. The hardware foundations and the birth of remote sensing in 1972 is launching Landsat 1 into the space. And the next era is called the commercial boom. It's starting from the 1980s to 1900s. It's a GeoTIFF emergence and the JS speed of the in its application of GIS. For example, is ERDAS imaging, ArcGIS, and etc. So in the era is called the modern era. It's starting from the 2000s to the 2020s. It's a Thai web map. It's like the Google Map is starting. Cloud processing like the Google Ad Engine. And special temporal data is for the improvements. And right now, in 2025, it's called the Future 10 and beyond the next era. Future 10 is the neural compression in on-demand in mapping and real-time the digital twins. Why COG is the foundation in the context of the modern GIS and evolution of the raster data. We just discussed the cloud optimized GeoTIFF like COG. It's considered the foundation because it solves the big data bottleneck. Before it's the COG. If you wanted to analyze small farm or some plot in a farmer in a massive satellite image, you have to download the entire multi-gigabyte file first. COG is a chain game by allowing software to stream only the specific pixel needed when I store data in the cloud, in the like AWS S3. So this is the COG timeline. COG is starting from about 2015. The concept was first demonstrated at scale when Amazon Web Service began hosting the Landsat Edge archive. And the next in 2016 to 2018, it's called the development. The formal COG name and technical specification were developed within the open source community, specifically spearheaded by the GeoTIFF. GeoTIFF is the library of Python for the processing data in remote sensing and satellite data. And the next in the course is starting from the 2019 to 2021. A major government agencies pivoted. The USGS converted this entire national map and evaluation archive the COG in 2019. So in the 2023 to 2024, sorry, the Open Geospatial Consortium is OGC. It's officially ratified COG in 1.0 as a global standard. What is the EDR? EDR OGC stands for the OGC API. It's called the Environmental Data Retrieval Standards. It was officially ratified in 2021, and it's called part of the modern and cognitive GIS era. That is the important thing from the EDR is sampling specific value from the big data and simple and lightweight for developer friendly. So for my experience, when I found the problem, the problem is when I use the default COG is insufficient for optimizing the use of EDR in the project. And the most important the issue is the problem of increasing storage space. And the last issue is the latency of OGC when the data retrieval speed from the API. So from the problem increasing storage space, when purchasing storage might not be the best option at that moment. I mean in last year. So we can have find solution, and we discussing in our team for how to reduce file size and how to it could be to lead to the performance of the retrieval when file size is reduced. So so this is method scenario. I use the data set and NDVI from the Sentinel-2 data and environment of store data in AWS S3. And tool for create COG files, I use the GeoTIFF. And this is some script. It's just a little script for the create COG files. And I split the script for how to create, how to generating COG and how to validating COGs. So when we have the methodology and scenarios, I will run script for the in each parameters. Okay, parameter I use the parameter of completions and parameter of block size. So in the first parameter of the completions, by default from the COG input, by default from the when create COG. COG when I use the GDOL is default by the LCW parameters. Okay, and the file size for my default for the testing scenario list is allow 360 megabytes. And we try three parameters completion from the COG. Finally, we find out the parameters from the best parameter from my experience. The best parameter from the reduce file size is the parameter is CSTD parameters from the file size is allow reduce file size allow from the default parameter about 23%. Okay, so this is the I/O performance when I use parameters block size when create the COGs. So this is the latency when I use list data from the AWS S3. So I found out the reduction in time when block size is parameter is 256. 56 is the pixel block size from the COG. In my step I send the bbox upload from the example and send bbox plot to the lead file in AWS ST. And the integration of using in my job for to optimize COG into the real case, I bring one of our project in company. Use case is the Dragonfly GSR for agriculture platform. Dragonfly for architecture platform in the specialized for the analyze the data from satellite data. Is the monitor of the crop health or fertilizer recommendations. relate on the time series data. In this video, demonstrate when I send this was in the client side for the send the plot lead like an lead data from the S3 in the when lead time is success bring the result in the US in the web on the confined register lead on the time series data. Okay, try it again. So actually, we use the stack collection for the store the data in the on the time series when I use the EDR APIs. In the future tense, we are currently we are not we are sorry in our companies currently we, is working on and developing this tense for the futures. And now we use the stack integration and HTTP link request GeoTIFF like EDR API as well. And to the next step, we have planned to the user the independent data and delivering delivery the data in the future. So in conclusion, I sincerely hope that this my method will be beneficial to our companies, to our communities. Sorry. Thank you for your time.
Yeah. Are there any questions? Yeah. Just
Hi, first of all, thanks for the amazing presentation. My question is that why your tile sizes when it was 128 pixel, latency was more than 256 when tile size was 256?
Sorry, please.
Okay. My question is that why latency was more in 128 pixel size in tile. Can you go back to slide number 11?
Number 11, yes.
Yeah. So first one, why 128 pixel is having more latency than 256 pixel?
So it depends on it depends on the file size before the COG in it depends on the B B box from the data from the setting when we use the when we send the B box from lead data from the S3. Yes.
Okay. Thank you.
yeah. Any other questions? Yeah. Thank you.
Thank you so much.